Have you ever wondered what the universe looks like when everything goes completely silent? Not the silence of a quiet night on Earth, but the silence that exists between galaxies, where a single atom can drift for thousands of kilometers without touching anything at all. And here's something even stranger. What if I told you that right now, ancient particles of light, older than Earth, older than the sun, are passing through your body as you breathe? Where did they come from? How long have they been traveling? And what hidden stories do they carry across billions of years? Tonight, we're entering a place where galaxies glow with memories, where stars hum softly through the dark, and where the entire universe moves in one slow, gentle rhythm. A rhythm you can fall asleep to. So let your shoulders drop. Let your eyes soften. And hold on to this question as you drift. What is the most peaceful place in the whole universe? And why does it exist at all? The answer is somewhere in the quiet that follows. Hello and welcome to Sleep Quotes Lab. I'm really glad you're here tonight. Let this be your quiet moment to unwind. Wherever you are, slow your breathing, soften the sounds around you, and let your thoughts float down like leaves on a still pond. If these peaceful stories bring you a little comfort tonight, feel free to like, comment, and subscribe. It quietly helps more sleepy souls find their way here, and it truly means the world to us. Let's begin. The shape of space might hold even stranger surprises. The universe may not have an edge at all. It could go on without limit, or curve so gently that if you traveled straight in any direction, you might eventually return to where you started without ever encountering a wall. Like walking around a sphere without knowing you're looping back. Even our own sun may have had a lost companion. Most stars are born in pairs, and some astronomers believe the sun might have once shared its birth with a sibling star. Over billions of years, gentle gravitational tugs could have pulled them apart. If that sibling existed, it now wanders the Milky Way alone, far from the sun we see each day. Neutron stars offer another quiet wonder. They're tiny, only about 20 kilometers wide, but heavier than the sun itself. If you could scoop a single teaspoon of neutron star matter, it would weigh billions of tons. A single raindrop of it would outweigh mountains. Inside these stars, atoms are squeezed so intensely that the familiar structure of matter collapses into something dense and strange. A silent, heavy memory of a star that once burned bright. Gravity itself can twist light, bending it as it travels across space. When light passes near extremely massive objects like galaxy clusters, its path curves. A single distant galaxy can appear multiple times from this effect, stretched into arcs, mirrored images, or even perfect glowing rings. Sometimes light takes several different routes to reach us, arriving at slightly different times. A cosmic echo in the shape of light. The very first stars to shine were nothing like stars today. Born from pure hydrogen and helium, they grew enormous, hundreds of times the mass of the sun, and burned with incredible brightness. 1,000,000 times brighter than our star. They lived short, intense lives and then exploded, seeding the universe with the first heavy elements. Everything you know, planets, metals, life, comes from the ashes of those ancient giants. Right now, as you lie here, dark matter passes through you silently. Trillions of particles each second, drifting through your body without leaving a trace. Invisible, untouchable, but essential. Dark matter holds galaxies together, shapes cosmic structure, and fills the night with something unseen yet present. Even in sleep, it travels through you. Far from bright galaxies, astronomers have found faint systems filled with gas and dark matter, but almost no stars. Ghost galaxies, barely glowing, almost invisible. Some may have lost their stars long ago. Others may never have formed many to begin with. They drift like forgotten chapters of cosmic history. And deep in the cosmic microwave background, the oldest light we can see, there is a strange, cold region, much colder and larger than expected. Some believe it's the imprint of a giant empty void. Others wonder if it hints at something even stranger, perhaps an early brush with another universe. No one knows for sure. It doesn't shout for attention, just rests quietly among the patterns of ancient light. Meanwhile, here at home, the moon is slowly slipping away from Earth. About 3.8 centimeters each year, a small drift, the pace of growing fingernails. Long ago, the moon was closer, and Earth spun faster beneath it. Over time, this gentle retreat continues, shaped by the slow tug of tidal forces. Someday, far, far in the future, Earth and the moon may face each other permanently, locked in a cosmic gaze. For now, the moon simply drifts, quietly, almost invisible in its slow departure. And in some places where stars orbit each other closely, their outer layers touch. Gases spill from one to the other in slow, swirling streams. Sometimes this exchange is peaceful. Sometimes it ignites bright bursts of activity. And sometimes two stars merge, becoming one. A delicate dance unfolding over millions of years. Astronomers often say the universe is around 13.8 billion years old. That number comes from studying the soft microwave glow left over from the Big Bang and watching how galaxies drift apart. But some stars look older than they should be. Some galaxies appear too mature for such an early universe, and the way the universe expands might not be as simple as we thought. Maybe our calculations are correct, or maybe the universe began longer ago than we can comfortably imagine. A soft uncertainty at the edge of our understanding. There are also worlds with no sunrises at all, planets that wander alone through endless night. These rogue planets float freely, unbound by any star. Some were born beside suns and later flung into the dark by chaotic gravity. Others may have formed in silence from the beginning. Astronomers think there may be billions of these lonely worlds, cold, shadowed. Some theories imagine that the universe itself might live in cycles. Not one beginning, not one ending, but a long rhythm. Expansion, slowing, collapse, and another beginning born from the last's quiet end. Like a universe breathing in and out across eternity. Before any galaxies formed, before stars were born, Space was a bright, hot fog. Light couldn't travel far. It bounced and scattered like echoes in a dense cloud. But then, about 380,000 years after the Big Bang, everything cooled enough for atoms to form. Suddenly, the fog cleared, and light could finally move freely. That same ancient glow still surrounds you now, stretched into soft microwaves by billions of years of expansion, a faint whisper of the universe's very first moment of clarity. In distant star systems with unusual chemistry, entire planets may transform into massive crystals. Under immense pressure and rich carbon conditions, some worlds solidify into diamond-like structures. Astronomers have found at least one such world orbiting a dead star, a planet that may be almost pure crystal underneath its blazing hot surface. A diamond planet, shining silently in the dark. Even in the deepest parts of space, places with no stars, no planets, and almost no atoms, there is still a quiet shimmer of activity. Quantum physics tells us that space is never truly empty. Tiny particles appear and disappear so quickly you couldn't catch them, not even in thought. This constant flicker forms a restless foundation beneath everything, like a soft hum beneath silence itself. Some scientists believe this subtle motion may help explain dark energy, the mysterious force that pushes the universe apart. Even nothing has a pulse, gentle, invisible, always there. And time itself isn't as steady as it seems. We think of it flowing like a smooth river, the same everywhere. But time bends with gravity. Near massive objects, it slows down. A clock placed near a dense cluster of galaxies ticks more slowly than one far away. We've tested this with satellites and atomic clocks, and the results match Einstein's predictions perfectly. So, somewhere far across the universe, time may be drifting at a slightly different pace than the time you feel now. A quiet reminder that even the simplest things, like a second, can behave differently under the weight of the cosmos. Our own galaxy, the Milky Way, is more than the glowing spiral you see in illustrations. Surrounding it is an enormous invisible halo made of hot gas, ancient stars, and vast amounts of dark matter. This halo is so large that the bright disk we picture is only a small part of the whole structure. We know it's there because of how stars move, faster than they should if only the visible matter existed. Something unseen holds it all together like a gentle cosmic scaffolding. And through that halo, through all of space, ancient light travels. With new tools like the James Webb Space Telescope, astronomers have found galaxies whose light set out only 200 million years after the Big Bang, barely a moment after the universe first lit up. That faint glow traveled for more than 13.5 billion years to reach us. When we see it, we aren't just looking far away. We're looking deep into the universe's childhood, peering through a narrow window that shouldn't exist, and yet somehow does. When astronomers map galaxies across enormous stretches of space, a strange pattern appears. Threads, clusters, and empty regions forming a vast network. This cosmic web looks surprisingly like the structure of a human brain. Neuron-like nodes, filament-like connections, a pattern echoed across scales separated by billions upon billions of times. It doesn't mean the universe is thinking, but it's comforting somehow to see a familiar shape woven into something so immense. Even stars have their own quiet music. Inside them, waves of pressure bounce and ripple, making the whole star vibrate gently. These vibrations change the brightness in tiny ways, too subtle for your eyes, but easy for telescopes to read. By listening to these silent stellar songs, astronomers can peek inside stars, how they spin, how dense they are, even how old they might be. It's like tapping on the shell of an egg and hearing the echo of the life inside. Many stars carry ages older than the galaxies they now live in. Galaxies collide and merge throughout cosmic history, and when they do, they bring their stars with them. Some of these older stars have chemical fingerprints from a younger universe. Simple atoms, almost untouched by generations of star formation. They drift in the outskirts of galaxies, ancient wanderers that began their journey long before their current home even existed. But not everything follows our expectations. Some galaxies seem to lack dark matter entirely, a puzzle that doesn't fit smoothly into our models. Their stars move as though only visible matter is present, which contradicts what we see in most other galaxies. Maybe their dark matter was stripped away by interactions. Maybe they form differently. Or maybe dark matter itself hides properties we haven't discovered yet. The universe enjoys keeping a few secrets. Even our sun isn't silent. Deep inside it, sound waves ripple through its plasma, making the entire star vibrate like a slow, steady drum. These waves bounce, echo, and create tiny shifts on the sun's surface, too subtle to notice with your eyes, but detectable with sensitive instruments. Studying these hidden pulses reveals the sun's inner layers, its density, rotation, and currents. It's a cosmic instrument always playing, even when we don't hear a thing. Galaxies themselves follow invisible paths shaped by dark matter. Huge filaments, made not of stars, but of something unseen, stretch across space, guiding galaxies like beads strung on threads. These structures are enormous. Some span hundreds of millions of light years, and yet they're invisible to normal light. We only know they exist because galaxies gather along them and light bends subtly as it passes through. Dark matter forms the skeleton of the universe, and everything else follows its quiet design. Even space itself has surprising freedom. Nothing can travel faster than light, but space can expand faster than light travels. During the early moments after the Big Bang, space stretched so quickly that distant regions were pulled apart faster than light could move between them. Even now, far-off galaxies move away from us faster than light, not because they're traveling quickly, but because the space between us and them is growing. It's not a violation of physics, just space doing what space does. And as space expands, our entire solar system spirals through the galaxy. The planets orbit the sun, yes, but the sun itself is racing around the Milky Way at nearly 1,000,000 kilometers per hour. So the planets aren't drawing perfect circles. They swirl behind the sun in a graceful corkscrew pattern, drifting through the galaxy like ribbons caught in wind. Even when we lie still, everything around us is moving with soft, unstoppable elegance. Far beyond stars and planets, even in the emptiest voids, space has a temperature, about 2.7 Kelvin, just above absolute zero. This faint warmth comes from the leftover glow of the Big Bang, now stretched into microwaves as the universe expands. No matter how far you travel, that soft thermal whisper follows, a last remnant of the universe's first light. The earliest moments of everything may have been shaped by the smallest possible fluctuations, tiny jumps in quantum energy magnified by cosmic inflation into galaxy-sized structures. In other words, the universe we see today, galaxies, clusters, voids, might all trace back to tiny, random trembles in the fabric of reality itself. Everything big, beginning from something so small it can barely be imagined. And not all stars end in explosions. Some fade in slow motion, expanding and shrinking in rhythmic cycles during their final stages. These variable stars brighten and dim like breathing embers, repeating their patterns with gentle precision. Astronomers use these cosmic heartbeats to measure distance across the universe. A single pulse, repeated over time, revealing how far away a star truly is. And somewhere in the middle of all this, our entire solar system floats in a vast bubble of hot gas, the local bubble. It was carved by ancient supernovae long before humans existed, leaving a cavity hundreds of light years wide. It is the universe's largest pattern, woven across distances too large to imagine, and yet delicate enough to resemble the branching of neurons in a brain. Some of the galaxies we see with powerful telescopes no longer exist as they appear. Their light began its journey billions of years ago, long before Earth formed. By the time it reaches us, those galaxies may have merged, transformed, or faded completely. We're looking at ancient snapshots preserved in the darkness, pieces of cosmic history still traveling toward us. The light from many distant galaxies left its home before the sun was born, before our planet existed, before life even had a chance to begin. What we see tonight is a message from a time older than Earth itself. And even something as huge as a galaxy can vanish behind drifting clouds of interstellar dust. These dust grains, tiny pieces of carbon and silicates, float through cold regions of space and block visible light. But when we look with infrared or radio telescopes, hidden galaxies suddenly appear behind what once seemed like nothing at all. In space, darkness doesn't always mean absence. Sometimes it's simply a veil waiting for the right kind of light. If the alignment is perfect, a distant galaxy can be stretched into a glowing circle around a closer one, forming an Einstein ring. It's a natural lens created by gravity bending light, turning distant galaxies into perfect geometric halos, elegant, silent illusions drawn by space-time itself. When we speak of the universe stretching outward, it's natural to ask if it has an edge. But every observation so far suggests that space may continue endlessly. No boundary, no border, no final wall. The part we can see is only the observable universe, a small bubble of visibility inside a much larger, possibly infinite whole. Even tonight, cosmic rays, tiny, high-energy particles, strike Earth from faraway galaxies. They travel at incredible speeds, some crossing the galaxy for millions of years before hitting our atmosphere or passing quietly through your body. Invisible, harmless. A reminder that even now, we're connected to distant events across the universe. The idea of before the Big Bang may not even make sense, because time itself may have begun with that moment. Asking what came before is like asking what lies north of the North Pole. Some theories imagine earlier universes or quantum states without time, but most models suggest that the Big Bang was not an explosion in space. It was the beginning of space. Even our understanding of distant cosmic objects has changed. When quasars were first seen, they looked like faint stars, tiny points of light, but their spectra were strange, and their brightness flickered in unusual ways. Eventually, astronomers discovered that they were not stars at all, but the blazing centers of galaxies, powered by supermassive black holes devouring matter. Some of the brightest objects in the universe, hiding in the form of small, flickering dots. And our own galaxy isn't standing still. The entire local group, our cosmic neighborhood of dozens of galaxies, is drifting toward a massive, unseen region far beyond the Milky Way. This slow movement has been measured, but not fully explained. It's as if our whole neighborhood is sliding towards something enormous, hidden behind clouds of gas and dust. Right now, we live in a bright season of the universe, what some call cosmic springtime. Stars are still forming, galaxies are still active, new light is still being born, but this will not last forever. Star formation has already passed its peak. Far into the future, it will slow, fade, and eventually stop. Still, tonight, the universe is alive with new beginnings. One day, long after we're gone, galaxies will run out of the cold gas needed to form stars. Slowly, gradually, the lights will go out. Bright blue giants will vanish first, then suns like ours, then the smallest red dwarfs, burning their fuel with incredible patience. The universe won't end suddenly. It will dim gently, like a candle burning down over trillions of years. Most of what exists in the universe is invisible. We see stars, planets, and dust, but all of this is only a thin surface layer. The vast majority of matter is dark matter, silent, unseen, detected only by how it shapes gravity and curves light. It's the hidden skeleton of everything, holding galaxies together and guiding their formation. The light from the first galaxies didn't simply travel, it stretched. As space expands, light waves stretch with it, shifting into redder, longer wavelengths. This cosmic redshift tells astronomers how far light has traveled and how old its source is. The deeper the red, the older the message. Some scientists even wonder if our entire universe might be a kind of projection, like a hologram. Not in a fantasy sense, but in a mathematical one, where all the information that forms reality could be encoded on a distant surface. Even if the idea never proves true, it reminds us that reality may be more layered than it appears. Space, too, might not be perfectly smooth. Some theories suggest that at incredibly tiny scales, far smaller than atoms, space is grainy, like pixels in an image. We can't test this yet, but if it's true, the universe has structure all the way down, even in what appears empty. Some stars spin so quickly that their shapes bulge outward at the equator. Neutron stars, especially millisecond pulsars, rotate hundreds of times per second. A city-sized object spinning faster than a blender blade. Their beams of radiation sweep across space like cosmic lighthouses, ticking with remarkable precision. As for the universe's end, it may come not with a bang, but with a quiet fading. As the expansion continues forever, galaxies drift apart, stars burn out, black holes evaporate, and space grows colder and darker until even the last traces of heat dissolve into silence. A soft ending to a vast story. Some galaxies breathe, not with air, but with powerful winds blowing out from their centers. These superwinds push gas, dust, and newborn stars into intergalactic space. They can reshape entire galaxies, shutting down star formation and sending heavy elements drifting into the cosmic web. In the far future, when stars are gone, when black holes have faded, the universe may become an endless, dark ocean. Sparse particles drifting through cold space, a long quiet after a bright beginning. There's even a chance that we live inside a cosmic void right now, an underdense bubble compared to the average universe. It wouldn't change our daily lives, but it would explain some mysterious patterns in cosmic expansion and temperature. Magnetars, those fierce remnants of collapsed stars, carry magnetic fields trillions of times stronger than Earth's, strong enough to distort atoms, strong enough to erase data from far away. These fields are temporary, fading over time, but while they last, they make magnetars some of the most extreme objects known. And one of the largest structures ever found in the universe is a vast cluster of quasars stretching billions of light years across. So immense, it challenges our understanding of how large structures can be. Black holes twist space and time into something like a funnel. As you approach the event horizon, time slows, space stretches, and inward becomes a direction you cannot escape. Some regions of the universe are already too far apart to ever communicate again. The expansion of space carries them away faster than light can cross the distance. Those places will remain forever separate, unreachable, even in infinite time. Many of the heaviest elements, like gold, were born not inside stars, but in the violent collisions of neutron stars. Two dense remnants smashing together with unimaginable force, scattering heavy elements across space. Your jewelry, your electronics, even the gold in your bloodstream came from these cosmic collisions. The space between galaxies continues to stretch, and light stretches with it. What begins as bright starlight eventually arrives as a soft whisper in the infrared. Even before the universe became transparent, sound waves rippled through its hot plasma. These ancient vibrations left a frozen imprint on the arrangement of galaxies today, a fossil of cosmic sound still echoing across space. Galaxies sometimes swallow their smaller neighbors completely, leaving only faint streams of stars as evidence. These stellar trails wrap around the larger galaxy like threads pulled from an old cloth. Some stars seem to flicker as they brighten and dim over time, gentle, predictable rhythms caused by internal waves or orbiting companions. Their patterns help astronomers measure vast distances with striking accuracy. And some black holes drift alone through space, kicked out of their galaxies after violent mergers. They wander silently, nearly impossible to detect, carrying only their gravity with them. Even black holes can be pushed. When two merge, the burst of gravitational waves can shove the new black hole away at tremendous speed, sending it flying through the galaxy. Some white dwarfs, the remnants of stars like our Sun, may crystallize over time into enormous diamonds. A whole star turning into a silent, cooling jewel. And despite everything the universe has already lived through, the future ahead is even longer. Trillions of years still waiting, full of slow changes we can barely imagine. When a star explodes, its leftover shockwave expands for thousands of years, forming intricate shapes of glowing gas. Supernova remnants still unfolding long after the initial flash has faded. Even a planet can bend light, creating a tiny gravitational lens that reveals its presence as a subtle dip or rise in a distant star's brightness. Some regions of space cool more slowly than others, holding heat far longer because of the matter they contain. And in some theories, new universes could form inside black holes or quantum bubbles, new beginnings branching from quiet endings beyond anything we could ever observe. Even now, faint echoes from the earliest moments of the universe may still ripple through space as gravitational waves we haven't yet learned to detect. Some of the oldest objects in space are white dwarfs, tiny, dense star remnants that slowly cool over billions of years. Although they shine softly, not a single one has ever cooled to darkness. The universe simply hasn't existed long enough. Every white dwarf that ever formed is still glowing somewhere in the night. Not all galaxies are spiral or oval. Some stretch into thin strands known as tidal tails, long arms pulled out during close encounters with other galaxies. These luminous trails can extend for hundreds of thousands of light years, like wisps of starlight brushed across the dark. And hidden far away are dwarf galaxies, tiny collections of stars orbiting larger ones like quiet companions. Some are so faint they blend with the night sky, invisible even through strong telescopes. Yet, they carry ancient stars, older than most in the Milky Way, preserving memories of a younger universe. The arrangement of galaxies across the cosmos didn't form randomly. Patterns we see today, clusters, voids, and filaments, are the enlarged remains of tiny fluctuations in the early universe. Those gentle ripples expanded over billions of years into the cosmic landscape we observe now. The universe's largest structures began as the smallest trembles. Near the cosmic dawn, enormous clouds of gas collapsed to form the first galaxies. They were not like modern galaxies. They were smaller, hotter, more chaotic. Stars formed rapidly inside them, burning bright and dying young, filling the early universe with heavy elements for the first time. Even today, some galaxies continue to collide. These mergers are slow, so slow that entire civilizations could rise and fall before the shapes noticeably change. But over millions of years, the graceful dance reshapes both galaxies into something new. Close to home, the solar system travels through the Milky Way inside a beautiful curved arm known as the Orion Arm. From here, stars around us look scattered randomly, but on a grand scale, they form a thin, glowing river of light winding around the galaxy's center. Inside that river, our sun carries its planets along, like a small lantern drifting in a vast, starry sea. Sometimes, galaxies form enormous arcs of stars, shaped by the gravity of nearby clusters. These arcs stretch like cosmic waves frozen in motion, revealing how gravity sculpts the very fabric of space. And in the emptiest regions, cosmic voids, galaxies are rare and isolated. These lonely areas can stretch for immense distances without much matter, creating enormous pockets of deep darkness. They are some of the most peaceful places imaginable. Magnetic fields weave throughout the universe, invisible but influential. They guide charged particles, shape gas clouds, and help form stars. Though we can't see them directly, their effects ripple across galaxies like unseen threads pulling everything into gentle motion. The first black holes may have grown surprisingly quickly. Baby galaxies often show signs of enormous black holes already in place, suggesting that these giants formed in ways we still don't fully understand. Perhaps from collapsing stars, or perhaps from dense clouds collapsing without ever becoming stars. Even the light from distant quasars flickers as it passes through intergalactic gas. These tiny flickers tell astronomers what the universe was like billions of years ago, how hot the gas was, how dense, and how it changed over time. Far in the distance, galaxy clusters, immense gatherings of hundreds or thousands of galaxies, sit at the intersections of the cosmic web. Between them lies a thin, hot plasma called the intracluster medium. It glows in X-rays, revealing webs of invisible matter and tangled magnetic fields. Some clusters hold galaxies that seem frozen in time, their star formation long finished. These galaxies glow with warm, ancient starlight, the light of stars that were old before Earth existed. The most distant objects we can detect are not stars or galaxies at all, but faint radio signals and relic photons that traveled from the earliest moments of space itself. Each tiny speck of radiation carries a story from the universe's beginning, whispering across billions of years. Throughout the universe, galaxies behave like islands in a vast ocean, drifting slowly through a sea of dark matter. Their motions reveal currents and tides, in the invisible substance surrounding them. Space itself may have a shape beyond our imagination. It could be curved like a sphere, saddle-shaped, or perfectly flat. Every measurement so far suggests near flatness, but the true shape may only appear at scales larger than we can observe. The most energetic particles in the universe, ultra-high energy cosmic rays, slam into Earth from unimaginable distances. Their origins remain mysterious, though they may come from black hole jets, supernova remnants, or even exotic processes we don't yet understand. If you look at two stars close together in the sky, they might not be siblings. One could be near, one far away. But if you find a true binary pair, they dance through space together, orbiting their shared center of mass across millions of years. Many of the stars visible to the naked eye are actually multiple star systems. Some stars form planets, while others form entire disks of gas and dust that glow in infrared light. From these disks, planets slowly gather, grains of dust sticking together, growing into rocks, then worlds. Each planet is a long story of collisions and quiet accumulation. In some parts of the universe, ancient galaxies still hold leftover gas reservoirs. If disturbed by gravity or collisions, they can flare up with new star formation, briefly lighting again before fading into silence. The interstellar medium, the space between stars, is filled with faint clouds of gas and dust. These clouds form beautiful shapes when illuminated by starlight. Glowing nebulae, dark tendrils, and colorful ribbons. They are the birthplaces of new stars, slowly collapsing under their own gravity. Space is not silent in every sense. Waves of plasma, bursts of radiation, and flows of charged particles create patterns that instruments can translate into sound. The sun hums. Earth's magnetic field whistles. Jupiter's radiation belts crackle softly, a cosmic symphony heard only through special ears. Some galaxies harbor rings of stars instead of spirals. These rings may form from collisions or resonant patterns deep within their structure. They glow like gentle halos wrapped around the galaxy's heart. Inside galaxy clusters, galaxies move at incredible speeds, sometimes up to 1,000 kilometers per second. Their motions stir up gas, triggering long filaments of glowing plasma that drift between them like threads of light. And beyond all of that, there lies the quietest mystery of all. The expansion of the universe is speeding up. Something, dark energy, pushes galaxies apart with increasing force. It is everywhere, invisible, woven into space itself. It may determine the fate of everything, guiding the universe toward endless expansion and a distant future of deep, gentle darkness. Even with all this mystery, all this immensity, the universe remains calm tonight, stretching slowly, shining softly, whispering through starlight as you breathe. Some of the most powerful events in the universe leave barely a trace of light. When two black holes spiral together, their final moment is silent, invisible, and yet so intense it sends ripples through space-time itself. These ripples travel across the universe until they pass through Earth as faint whispers, tiny stretches and squeezes smaller than an atom. And yet, with the right detectors, we can hear that whisper from over 1 billion light-years away. Not all galaxies glow with stars. Some are dim, shadow-like systems filled mostly with dark matter and thin gas, with barely any starlight of their own. They drift quietly through space, shaped by gravity, but shining only faintly, if at all. They remind us that even the silent parts of the cosmos hold stories. Many galaxies slowly lose their star-making gas to gentle winds or to the tug of nearby clusters. As the gas drifts away, the galaxy grows quieter, forming fewer and fewer stars until its light becomes warm and soft, like an ember cooling after a long burn. The early universe was a place of glowing fog, hot, dense, and bright. Back then, light could not travel freely. It scattered until the universe cooled enough for atoms to form. Only then did the glow break free, spreading outward across billions of years. We still detect that ancient light today as a faint microwave whisper surrounding us like an invisible blanket. Some distant galaxies appear distorted or stretched when viewed through giant galaxy clusters. Their shapes warp because the cluster's gravity bends the path of their light. Sometimes this bending produces arcs or even near perfect. Far beyond those clusters, faint galaxies shine with the soft glow of stars that no longer exist. Their light began traveling long before Earth formed, passing through expanding space until it reached our telescopes. To look at them is to look directly into the past. Inside the Milky Way, dust clouds swirl like dark rivers winding between stars. These clouds hide newborn stars inside their cores, wrapped in thick blankets of gas. Over time, gravity tightens its hold, and the clouds collapse until bright new stars ignite within. The dust eventually drifts away, revealing the stars that once slept in silence. The space between galaxies is extraordinarily cold, just a few degrees above absolute zero. Yet even here, particles move, quantum fields shift, and faint energy spreads through the dark. It is never truly empty, just very quiet. Some parts of the cosmic web stretch like glowing bridges between clusters of galaxies. These bridges are made of thin plasma and dark matter, invisible except to sensitive instruments. They connect enormous regions of space, forming a network that resembles delicate threads under starlight. Closer to home, our sun sings. It sends pressure waves through its body, causing it to hum with deep, slow oscillations. Scientists can detect these ripples and use them to study the sun's interior, like listening through walls to understand what lies beneath. Even planets leave marks in starlight. When a planet passes between its star and us, the starlight dims just slightly. That tiny dip, barely noticeable, can reveal the size of the planet, its orbit, and even hints of its atmosphere. A whole world discovered from a tiny flicker. There are stars that breathe in slow, steady rhythms. Their outer layers expand and contract, changing brightness over weeks, months, or years. From a great distance, they appear to be pulsing, like cosmic heartbeats, rising and fading across deep time. Supernova remnants continue expanding long after the explosion fades. Their shock waves carve swirls and filaments into the surrounding gas, glowing softly in beautiful shapes that drift for thousands of years. A star's final breath carried far into the galaxy. Throughout all these processes, dark matter silently shapes everything. It holds galaxies together, draws clusters into alignment, and forms the skeleton on which the visible universe is built. We cannot see it, but its presence guides the movement of stars and galaxies like a quiet, steady hand. And deeper still, in the earliest fraction of a second after the universe began, tiny quantum fluctuations stretched into the seeds of all cosmic structure. Those ancient ripples are still visible today, in the patterns of galaxies, in the maps of cosmic background radiation, in the quiet architecture of space itself. The universe holds memory in every direction, echoes of expansion, whispers of light, trails of stardust, and patterns woven across billions of years. Thank you, truly, for staying with me all the way until the last moment. In a universe this vast, with billions of stars glowing above us, the fact that you chose to spend these quiet minutes here means more than you know. I hope your mind feels lighter, your breath slower, and your heart a little more at peace. You are part of this universe just as much as the galaxies we explored tonight. A quiet, bright spark drifting through a beautiful, endless story. So as you sink deeper into rest, I hope your dreams are gentle, warm, and full of soft starlight. Let the world fade behind you. Let your thoughts settle like dust in a calm beam of light. You've made it to the end, and now you can let go. Close your eyes if you haven't already, and let the night hold you. Tonight, I wish you deep, healing sleep, a quiet mind, calm dreams, and gentle breathing. I wish comfort to your body, warmth to your heart, and peace to your thoughts. I wish freedom from stress, softness in every muscle, and rest that reaches your bones. I wish stillness in your spirit, a night free of worries, and a slow, steady heartbeat. I wish your mind to drift like a cloud, your dreams to feel safe, and your tension to melt away. I wish you the sense of being held by the night and the comfort of knowing you've done enough. I wish your day to end softly and tomorrow to begin with ease. I wish soothing dreams, a night wrapped in peace, and a body that relaxes fully. I wish your thoughts to fade like whispers, and your rest to feel sweet and deep. I wish you the calm of slow waves, sleep that comes naturally, and hours without rushing thoughts. I wish comfort from head to toe, the soft silence of midnight, and the stillness your heart needs. I wish you the peace your mind deserves, the softness your soul longs for, and dreams that refresh you. I wish you a night that heals, a pillow that holds you gently, and rest that feels like floating. I wish for sleep that renews your whole being, quiet joy in the dark, and the safety of a calm night. I wish your thoughts to settle like snow, your mind to let go with ease, and the peace of a star-filled sky. I wish you warmth, clarity in your dreams, and sleep that carries you kindly through the night. And I wish, above all, that you wake with a light heart, a clear mind, and a body fully refreshed.